Fantastic. All right. So we are off and running for the first day. So like I said, this is day one of Solar Panel Pros certification process and making solar smarter and teaching you guys the definitions and what goes into solar. There's going to be a lot of information in a very short period of time. It's going to be compacted together. There will be a cheat sheet, something you'll be able to download on the Document Center. It will be available on the app for you guys to have access to constantly, as well as in the Document Center to have access to constantly. And this will be uploaded to YouTube in a private format, unlisted, so you guys have access to it and watch it if you need to go back and re-watch the training itself. That being said, let's go ahead and get started. Today we're going to start on the solar definitions. We should get into the solar overview. If not, that's not a big deal. But definitely tomorrow we will be doing the solar storage aspect of it and starting on that, as well as getting you guys started on the appointment setting aspects. So we can get you guys going. You can start setting appointments as soon as Thursday morning for this weekend. So when you're certified, you can get out there, start knocking doors or start setting up funnels or start sitting down with people. You can start setting those appointments for Saturday. You can go in there on Sunday as well. And that way, if you guys get anything sold on Saturday, your managers will be available to help you. So we can get you one of those sales on this weekend. You get a sales weekend, that means you get a commission check next Friday. So definitely get out there, start working on those things. Try to get as many of those as you possibly can, starting on Thursday. So tomorrow we're going to be getting you guys certified on the appointment setting aspects, what you can, what you can't say, what you should say, what are good practices, what are appointment setting ethics, things like that. So we're going to go over some fun stuff like that tomorrow. Today is a solar definition. Once again, this will be accessible for you guys to go back and watch. There will be things you guys are going to feel a little bit overwhelmed. I completely understand. I've been doing this training for 7 years. Everybody who goes through the training the very first time feels like they didn't retain about 90% of what I said, and that's absolutely fine. So take some notes, but if we move too quickly, that's okay. It will be available for you to go watch. There will be a cheat sheet for you. But one thing that ends up happening is we talk about these things so much. As soon as I show you guys a proposal on Thursday and we go back over it on Friday, and you guys see this stuff go into the actual proposal, see the words on there along with the diagrams and with the pictures, you'll be surprised about how much information you retained during this training today on the definition process. Okay, so we're going to take up the entire two hours and 15 minutes on the training. We will take a 15-minute break so that you guys can go out there, grab a quick snack and do all that good stuff. So it'll be exactly 2 hours of intense training. There will be breaks to answer questions in between each little section, so we can go through. If we can get through a little bit quicker, get to the solar overview, that would be great. If we have to stop and ask questions, that's not a problem. Feel free to ask your questions, okay? I want you guys to be able to try to learn as much of it as possible. We will have some stragglers that come in a little bit late, and that's fine as well. We're going to have to get them caught up, so I might have to jump back if we went a little bit too far, but I'm not going to go back too far. I'm just going to cover some highlights for them. Their managers are going to be responsible for going back and getting that other stuff. If they miss too much, they'll be invited into next week's training. So that way they don't hold you guys back too much as well. Okay. First thing we're learning today is the electricity and solar and what it is. So you guys are going to get a little rundown about what electricity is and kind of how this stuff works, because it's good to have a good solid foundation and knowledge about what electricity is. Our first thing that we're going to learn on is electricity. So when you get your home energy bill, it's listed in kilowatt hours. But when you go to the store, you'll see things like 12-watt light bulb, 9-volt batteries. The vacuum cleaners are at like 15 amps of sucking power. So what do all these numbers mean? This is what we're going to go over today. All right. Is it because scientists hate us and they just want to throw out a whole bunch of terms? And is it because all the engineers just want to confuse you? No, it's not. We want to, there's different things, there's different categories and different definitions for each of these, and they all come together to kind of make the best possible outcome for whatever, the best possible output for the outcome that we're trying to accomplish here. So the main reason why is because several important things need to happen in order to be able to make an electrical circuit, okay? So electricity needs to flow. So you're going to see some examples today where we're talking about like water, because water flows. It'll help give you that good mental picture about what we're talking about here and how these things tie together. So an electrical circuit is something that needs to happen in order to be able to turn on electricity. So when you go turn on a light bulb, when you turn on the light switch, it opens or closes the circuit so that electricity will continue to flow, or opens the circuit. As soon as you close that circuit, you turn that light off, electricity is no longer flowing to the light bulb. It makes that cutoff. You need amps, you need watts, you need voltage, you need all this stuff in order to be able to get to that end point and create the circuit. So you kind of think of the circuit like a faucet on your kitchen sink. And when the water comes out, you need two things to make the water come out itself. You need pressure to force it through the pipes out of your faucet. And then the electrical circuit uses the electrons to carry the electricity, kind of like the water out of your faucet. But those electrons need something to push them along the circuit. Okay, and that's where we start talking about voltage. A force associated with the electric current that is measured and known also as volts. You guys have probably heard this term a lot. 9-volt batteries, things like that, right? High voltage. Power companies use high voltage to move electric power over long distances. So this is why you see high voltage signs. It's to be able to carry it along long distances, because voltage equals pressure. All right. So this electrical pressure is what we call voltage, and is often provided by two terminals. You need a positive charge, you need a negative charge in order to do it. So think about your car batteries, think about your AA batteries when you go switching them out of your remote. You have a positive end and you have a negative end. If you put them in the wrong spot, it doesn't work. The circuit's not complete. You need to put it in the right side to be able to complete that circuit and have a full, be able to provide the pressure to be able to go through that circuit. That's what the voltage does. So voltage equals pressure. Electrons flow from the negative end through whatever you're trying to power, and then into the positive end where they'll stay unless the battery is rechargeable. Okay. So on pretty much most of these disposable batteries that we see, what that means is they do not completely continue flowing through. That battery is actually storing all that stuff. Not storing it, but that's where they stay. It's not going to be used anymore. So we have to continually be swapping those things out. If you're plugging something into the wall, this voltage is instead provided by your power company. Okay, you're the end result. The light bulb turns on. You're not feeding that power back to the utility company. You're only getting into your wires what you're using. Although voltage is measured, as long as voltage just measures how strongly electricity is being pushed through the circuit, it's important because many circuits are designed only to accept a certain number of volts. It's important to know this because if somebody ever asks, well, I've heard that there's been a fire before. Yes, absolutely. The pressure can build up. So if you kink a hose for too long and you have a lot of pressure being pushed into that hose, eventually that hose is going to explode, right? If you push too much current through an electrical wire, that same type of pressure is going to end up building up. And if it builds up, it can combust and cause a problem. So voltage is usually one of those big reasons behind it. When it comes to amps, amp is short for ampere. It's not short for amplifier, which is all, it's a unit of electrical charge is flowing past a given point in 1 second. So amps equal flow, okay? So when you put the volts and the amps together, you can tell how much is flowing and how hard it's flowing, okay? So think of it like a water hose. You turn that nozzle, you get some good pressure coming out, you get good flow through it, and then at the very end of that water hose, you're going to have the ultimate, or the based off the pressure that you're pushing through it, you're going to have watts at the very end. That's where we're creating electricity. We're creating that final result. We're getting the water out of the hose or out of the faucet. So again, volts equal pressure, amps equal the flow that the electricity goes through, or in this case, water is what we're talking about because it's a good way to visualize it, because you use it more often. You can see it. You can't see the electricity flow. Now, guys, once again, you're not going to use 90% of this. You're not actually going to have to explain this to most of your customers. It's a good thing for you to understand kind of how this works, because every system's built a little bit differently. They require a different amount of power. There's going to be different size systems. We on the back end, and when the installers go to put this stuff in, we have to take all this stuff into account. So if you understand what we're taking into account, it makes it a little bit easier for you to start relaying information. So if we just recap briefly, amps is the flow and pressure is voltage. So we have a power formula here. It's really simple. Amp equals flow, P equals I times W. So your watts is your amps times your volts. So solar is rated in watts. You guys get paid off of watts. We build out the system based in watts. Customers pay their bills in kilowatt hours. You pay your bill in kilowatt hours, right? So in order to be able to determine that, we need to figure out the voltage and we need to figure out the amps, and then we can get the watts. So when you put the volts and the amps together, you can tell how much current is flowing and how fast it's flowing in order to be able to come up with your wattage at the very end. So the last thing we need to kind of figure out is the current, right? And the resistance. The resistance is like putting sand into the hose. It's going to cause problems along the way. It's going to start slowing down. It can start building up pressure. And the current is the diameter of the hose. So if you have a really, really small hose, like a water gun, and you start building up a lot of pressure, you're going to get a nice long stream shooting out of that. If you put the same amount of pressure through a larger diameter hose, that water is going to trickle out. But you have the same amount of watts that end up at the very end. Okay, so you can end up with the same wattage, but too big of a hose, it's going to run slow. Too small of a hose, it's going to add a lot of pressure. These are all things that we need to figure out when we're building out these systems on the back end, so the customer doesn't come up with problems in their system. Okay, so take a look at this. So let's say you have this. You want to hook up a water wheel to a generator, right? You want your own little hydro power going to a generator to power your home. So if a water pistol forces the water through the small nozzle, the total volume flowing per second, it's not a lot, but that high pressure is enough to turn the wheel. Okay, the wheel turning and how much is turning is the wattage at the very end of this process. If you have a larger diameter hose, just like we were talking about, it's going to come out, more water flows per second. It's going to end up spinning the wheel, but it spins it at the same speed, which means you ended up with the same wattage. All right. So I'm pretty sure a lot of you didn't realize you were going to be learning some of this stuff. Is anybody lost in what I'm talking about here? No? Cool. If you remember that voltage equals pressure, amps equal to flow, and the resistance is, and the current is the diameter in which it's coming out of, those are the main ideas that you need to have. So if a customer ever asks you like, hey, what size wire is it? Does it matter? Absolutely. Do we know when we're sitting down with them? No. We might know what wattage system we need to build on the house, but we don't know what their breaker is. We don't know if they're 220 or 200 or 150, if we need to upgrade them. We don't know the distance we need to run the wires, because the longer wire, we need higher voltage, more pressure to be able to get it from one end to the other. Right? So when we put in that scenario, does that kind of clear things up a little bit and make sense as to why you guys should probably know this? It's good to know. Will you know at the proposal? No, that's for the licensed electricians to go out there and solve after the fact. Does it matter what size wire we're putting on there, as long as we're putting on the right one when they're setting up for their system? It doesn't matter. We don't need to know that yet. We need to make sure that we know it once they want to get solar and we go start running all the tests. They go through permitting processes and they go through final inspections, not just by us, but by the city, to make sure that everything is done correctly, the right diameter wires on there, the right amount of voltage is going through it in order to be able to create the right amount of wattages, so that there's no issues that come up for the customer, no fire hazards and things like that. So this is why we learn this stuff. So if we look at the voltage, if we think of it like the water hose and the gun pushing out, right? Instead of a water gun, you could say that they're delivering the same amount of watts, right? So we went over that. If we put this in a real world scenario with electricity, let's look at a computer, right? So let's say you have a computer that's 1100 watt power supply on a full load, and you put it into one of our outlets here in America at 110 volt outlet. So what we're going to do is we're going to put that into the system, and it's to figure out the amps. because we have the wattage and we have the voltage, we need to figure out if the amps are going to be able to support it. So 1100 watts divided by 110 volts equals 10 amps. If we do it in a European outlet, which is a 220, we have the same wattage, we have the same voltage, it's 5 amps. We have the same wattage and we have the same voltage. Even though the amps are different, the computer will work, they'll work the same in both places. You won't have any issues with them. So the wattage and the voltage are the most important parts to look at. The flow, it might be different, but we're going to end up with the same result. The amp or the voltage and the wattage are going to end up the same. So as long as we get the same watts, the pressure is not going to be disturbed. It can be covered. You're in a good spot. All right. A kilowatt hour is a little bit different. So let's explain that. So why don't we go ahead and take a quick break for our questions, see what you guys have for me. Any questions on this stuff? A lot of crazy information. Again, it may not be stuff you're going to need to know when you're inside the house, like ever. If you do, you call one of us. Let's get one of the electricians to actually talk to them about it, or we'll talk to them about it. It's come up in 7 years. I've had to talk to one person about it because he was an electrician and he wanted to know everything. And it came down to, hey, we still have to do the site survey. We have to check out the utility box. We have to check out the wiring. We have to make sure the placement's right. We got to get on the roof. There's a lot of things that are involved in order to make sure that we get this stuff right. And he appreciated the answer because he knows that's actually what needs to happen. And he was testing to make, oh yeah, no, we're just going to do this. Don't lie to your customers. Okay. Don't be afraid to say, I don't know. There's going to be a lot of things you don't know, and that's okay. Get the answer for them. Hey, what's this? Honestly, I don't know. Let me find out for you, and get on the phone and call somebody who does. And if we don't know, we're going to tell you, yeah, no, I don't know, but I'm going to find out for you. And we're going to call somebody who does, and then we'll get back the answer right away. Lying to the customer is never a good idea. Faking your way through it is not a good idea. It's a horrible idea. Say, I don't know. Are you going to remember 90% of what you just went over? No, you'll probably remember voltage equals pressure. Great. Watts comes out of all this stuff. Great. That's the majority of what you need to know. You don't need to know how to calculate all of it. You don't need how to do all that crazy stuff. We're going to do that on the back end. The project designers do that on the front end when they're creating your systems for you. But you know that we had to take all this stuff into account when we're doing it. It also helps when you're creating systems or you're creating appointments for us to be able to show them a system design. Do you know all this stuff when you're initially talking to them? No. So we need to get a copy of their bill in order to get the electric bill to see if it even qualifies to do it. There may not be enough space on the roof. There may not be enough load on their utility box, or maybe too much of a load on the utility box. Or maybe there's a lot of different factors that go into this stuff to be able to create a proposal to see if it can even go onto the roof and not cause issues for the customer. So with that said, questions. We'll take 15 seconds to see if anybody has anything before I move on.
Yeah, I just have a quick one.
Yeah, go for it.
Well, I guess so. Basically, like you were saying, I just want to make sure I have it right. That's really important because you don't want to push too much to their house, because then that's when it causes problems.
Right.
Got that right. And then you were saying, so have you found that, like, that's important when, I guess, I keep around knocking doors, but we're trying to find people that, like, it's important to look, I guess, at the size of the roof. Like, do you find that that's, I don't know, kind of important to look at, so we don't like waste our time when you can like know offhand that it won't work?
So we'll know on the back end. So I mean, what we tell everybody, just get the appointment. Because if it doesn't qualify, if it comes back, it's like, hey, we took a look at the bill. We're going to be able to get a maybe 30% offset. They don't have enough roof space. You're going to get a message inside of your app that says this homeowner does not qualify. Too small of a system. And then you can call them. You don't have to go back and sit down with that customer. You can call them and let them know. The main job that we have as appointment setters when we're setting these things up as consultants is to consult them on what's going on with their system. It's the same thing with a doctor, right? If you go get blood work, do you want them not to call you? You want them to call you and let you know, hey, you're okay, or hey, there's a problem, right? So put yourself in that mindset when it comes to it. Let the guys on the back end who are building the system tell you whether or not it's going to qualify or not. There could be a shading issue. The customer wants to chop down the tree in order to be able to get solar on the roof. They don't care about the tree. Could be at first that, yeah, no, I don't want to cut down my tree. Okay, cool. Let me send it over to my designers. You tell the customer, well, hey, this is what you're going to save. They see what they're going to save. They get excited. What if I trim the tree back? That could work. Let's call the boss and find out. So there's a lot of different scenarios in there. It's better just to go ahead and set the appointment so that we can get the information. We don't know what they want to do. They don't know enough to, make that decision until we get the information, put it on, put an actual drawing on the roof for them. Does that answer your question?
Yes, thank you.
Cool. Anybody else? No? Okay, cool. All right. So kilowatt hours. Kilowatt hours is a unit of time. Just kidding. Kilowatt hours is a unit of energy. Okay. Why do they do this to us? Why do they say kilowatt hours and it's actually a unit of energy and not a unit of time? Do they hate us? Yes, scientists absolutely hate us. No, the reason why is because it's the length that here, what it is. Watts and kilowatt hours or kilowatts express how much energy is consumed per chunk of time. It is not the same as energy. Kilowatt hours is exactly this. So watt is the amount of energy or a joule. And then an electrical device such as a light bulb is burning per second and is running. So a 60-watt bulb is running 60 joules of energy per second that you have turned on. So when we look at the kilowatt hours, this is the consumption that you're being charged on by the utility company. It's not how many hours, it's the actual amount of energy that's being consumed by your home. In order to be able to figure out joules, it's just kilowatt times the hours equals the energy in joules. You're not really going to need to do anything like that, but what joules are is literally just a watt. It's just another term for a watt. That's the easy example of it. A watt is the amount of energy in joules that an electrical device such as a light or burning is burning per second that is running. Just remember that. If you hear joule, it's just a watt that is running per second. That's all we're looking at there. Okay. So just a simple term. We're going to be working in watts. We're not really going to be working in joules. If you ever see it come up, it's what it is. It's just the energy in joules that a watt, that an electrical device is burning per second. That's it. Okay.
Yeah, I really don't get energy.
So a watt, watts are defined as 1 watt equals 1 joule per second, which means that 1 kilowatt is 1,000 joules. Same thing with watt and kilowatt. So if you want to figure out what your wattage is, let's say it's an 8.5 kilowatt system, that's an 8,500 kilowatt system. You just take the wattage, you multiply it by 1,000, and you have you take your kilowatts, your wattage, your kilowatts, you times it by 1,000, you get your watts, your system in watts. And you can do the exact reverse. Okay, so if it's a 9,750 kilowatt or watt system divided by 1,000, that's 9.75 kilowatt system. Okay. If you want to determine, hey, look, 40 cents per watt or $400 per kilowatt. That's how you calculate your checks. That's how you calculate your commissions. When we're looking at the systems, they're going to be defined as the two of them. They're going to see sometimes where it says 8,700 kilowatt or 8,700 watts and 8.7 watts. What's the difference? Or 8.7 kilowatts. What's the difference? There's no difference. 8,700 watts is the same as 8.7 kilowatts.
Mhm.
It's the same size system. It's just watt times 1,000 to be able to get the kilowatts. 1,000 watts. That's it. A lot of information. I hope you guys get a little bit of better understanding about electricity and how that stuff works. Maybe a lot of stuff that you may not need to use inside of a house, like I said before. The things I want you guys to remember: voltage equals pressure, amps equals the flow, and your volts times your amps equals your wattage, your end output. Okay, we're looking for the watts when we're doing these systems. If you want to be able to get your kilowatt hours, we're on a completely different factor there. We're going to look into that more when we go into building the systems themselves. So hold on for that. But if you want to get your wattage of your system, or you want to get your kilowatt size on your system, if you had an 8.7 kilowatt system, that's 8,700 or 8,700 watts. If you want to reverse it, 9,250 divided by 1,000 is 9.25 kilowatts. Okay, a kilowatt is 1,000 watts. That's how you remember that one. Again, the local cheat sheet. Okay, now we're getting to actual photovoltaic solar. Let's talk about the actual photovoltaic solar and solar itself and how it works. Most of the contracts, when it comes to finance companies, most of the installation contacts, most of the stuff they look up on online, they all say photovoltaic. They don't just say solar. What is photovoltaic? Well, it's just the scientific term for solar. That's the biggest thing. When you see photovoltaic system, photovoltaic module, it means solar system or solar module. So if we take a look at a kilowatt as a measurement of power, well, a kilowatt hour is the length of time something can use a kilowatt. 1 kilowatt hour is equal to 1,000 watts sustained for 1 hour. So here's our kilowatt hour explanation. PV solar systems size is calculated in kilowatts. The size of the system is determined by how many kilowatt hours need to be produced. When we're building out these systems, we're going to be looking at their electric bill. Your electric bill, if you looked at it right now, just remember back to what we were looking at yesterday on the bill review, you're going to be seeing your usage in kilowatt hours. We're going to take that kilowatt hour usage, we're going to do our calculations, and we're going to figure out the kilowatt system size that needs to be installed on the roof to produce the proper amount of kilowatt hours to offset for the customer. That's what we're looking for when it comes to kilowatt hours. That's going to be the important part that we're looking for. What is the 8.7 kilowatt system going to produce in kilowatt hours? The PV system generates power from the panels. It converts it from direct current to alternating current at the inverter, which would be right here. Then uses it to power the home. Excess power generated is sold back to the grid in the form of bill credit. The system stops working when the grid is down. One of the reasons why, and you guys will see this especially on DG export areas, most net metering, the inverter actually connects directly to the utility meter. Then it feeds back into, then it feeds to the grid, and it feeds back into the electric panel through the meter. That's where you see these meters going forwards and backwards. Generally, this is just kind of how it works. This is just the very simplistic version of it. If there was no utility, the inverter, the important thing I want you guys to take away from this, what the inverter does. You need direct current from the panels, and you'll be storing direct current when we learn more about storage in the batteries. Alternating current is what your house uses. Some power tools have a converter because they need to be using direct current. You can take a look at some of these things on the side of your side of the stickers, on the warning stickers, on whether it's AC or DC power. All we need to know for the customer is you're going to be having AC power supplied to your home through your inverter itself. The panels collected as direct current, and we call it sun power to house power. Makes it a lot simpler to understand if you just do a little drawing for them, and we'll show you that one. Do a little drawing for them. The panels collected at direct current, sends it to the inverter, transfers it to alternating current, and then sends it to power the home. The other important thing to take from this, if the grid goes down, there is no power being supplied to the home from your solar panels. The reason why is because power still needs to go back to the grid as well. If they have workers working on the grid, there's power being sent back to the grid that can cause a hazard for their workers. There's no power if you don't have grid connectivity, unless you're off grid, which is very rare. Most of the people we talk to are not going to be living in an off-grid system. They're going to be living in a grid-tied system. They're going to be living under a utility company that covers an area, and as long as they can be connected to the utility, they have to be connected to the utility, so it'll always feed back. So if that grid goes down, if there's no battery backup, they do not have solar power running to the house. They will be just like every other home on the street. It's important to note that, and important to explain that to them, because that is the number one questions that comes from customers when we sit down from them. What happens if the grid goes down? Well, if the grid goes down, it has to feed power back to the grid. Because of that, you don't have power. They cannot have power being going back to the grid when workers are working on the system or working on the grid itself.
Safety.
So with that in mind, here's how we size the system. So system size is determined off of those kilowatt hours. Here, there's 1,844 kilowatt hours on the previous usage, 2,062.27. Well, we can get this stuff. Most utility bills have the previous year's and the current year's production. We get these so we can size it properly. To figure out how your system, how to size your solar system, you take the kilowatt hour energy requirement and divide it by the total peak sun hours to get the kilowatt output. Then divide the output by your panels efficiency to get the estimated number of solar panels you'll need to use for your system. These are how we're figuring this out. So we need to start from the kilowatt hour in order to be able to get the kilowatt size system. Small brief section on what kilowatt hours are and how it feeds back to the grid. Do we have any questions on that?
What do we multiply the kilowatts with? How many hours of daylight? So where's that?
I'm sorry?
Oh, sorry, I didn't know I was on speaker. So, so the 1800
Sunlight hours, we're going to have an algorithm that I show you guys here in a little bit on how we do it. You guys will never actually do that for the customer, but I'm going to teach you guys how to determine the actual system size itself.
Okay.
So I'm going to turn on my light because it's starting to get dark in here. There we go. You guys can see me again. Any other questions about that stuff? No? Cool. That's it. A little bit longer of a section here. One of the reasons why this is directly impacts the customer solar production. So let's take a look at this. The direction of an azimuth is the direction of the solar panels from the observer, expressed by an angular distance from the north or the south point of the horizon to the point at which a vertical circle passing through an object intersects at the horizon. Don't worry about the definition. Look at this. Up at the top, we're at 0. Bottom, we're at 180, 270 on the left, and on the right, we're at 90. Which means in between, we're at 45, 135, 225, and 315. At the circle, we're at 360 degrees, which means at the top, we're at 0 or 360, comes to the same point, goes all the way around. This also looks a lot like a compass. This is actually how we determine the azimuth and what's going to be the best production for the customer. So that definition, all it means is north is going to be 0, south is going to be 180, east is going to be 90, and west is going to be 270, and then you can go in between. If it's due northeast, it's 45, and so on and so forth all the way through. So what does this mean for solar? The direction of the panels directly impact the production of the panels. You need direct sunlight in order to be able to produce the most power for your system. So if we're looking at the 0, 45, 90, 135, 180, 225, 270, 315, and then back to 0 or 360, depending on the position that the house is in, depending on the way the roof is facing, depending on where they're at in the country or in the world, they're not going to be the same in every single market that you guys are working for. This is one of the reasons why if you live in Arizona, you try to sell a system in Illinois, if you don't know what it needs to be there, we might be designing the system different there. You could give wrong information to the customer, which is why you need to be trained for what it needs to be over there. When it comes to the azimuth, we're going to be looking at the roof planes and which direction they're facing depending on where we're at. So I'm down here in Arizona, so I'm just going to use Arizona as the example. Okay. So the idea of production, the ideal solar azimuth for peak production is 180 degrees or due south down here in Arizona. From sunrise to sunset, the solar panels will receive the optimal amount of sunlight produced to produce the required kilowatt hours. This may vary depending on the customer's needs as well. So we're going to be looking at what's due south. Well, when we're looking at our maps are actually set up for north, south, east, and west. So when you're looking at the top of your roof on Google Maps and you scroll in to see if they've updated your image or if it's a 4-year-old car that's sitting in the driveway, you're looking at it from a northern position as a standard. So we're doing the same thing when we build out these solar systems. So when you see a picture with a solar system on it, you know that we're looking at it from north, south, east, and west, okay? When we're mixing multiple azimuths, the factor changes and requires a higher kilowatt system to produce the same amount of kilowatt hours. The reason why this is so important, you guys need to understand, let's say we're trying to build a system for myself and my neighbor who have the same design on the house, but he doesn't have these, or say I don't have these and he has these, okay? Well, great, I can put panels here, I could put panels here, and I lucked out, that's a big enough system to cover my entire needs. Well, my neighbor has the exact same utility bill that I do, we use the same amount of electricity, but he has these little extra rooms back here that are blocking putting panels here. So we're gonna need to put more panels here and here to be able to produce the same amount. So let's say I need an 8 kilowatt system and I'm facing due south. Well, my neighbor may need a 9.1 or 9.2 kilowatt system to produce the same amount of kilowatt hours as my 8 kilowatt system does. The reason why this is so important to know is because when you get referrals and when you're talking to neighbors and when you sell your customer's sister or brother or just friend of the family and say, oh yeah, no, our bills are pretty much exactly the same. Why is my bill so much higher? This could be one of the factors that came into play. They might have an east to west facing roof and the original customer had a due south roof and it was perfect for solar production. But because of about right here on an east to west, the sunlight, there's not going to be as much direct sunlight on this one as there will be on all the due south. So you're going to drop production on these panels, but you're going to increase production on these panels over here. But while the sun was rising to get to the midpoint, you weren't getting as much solar production on these panels as you were on these panels. I'm going to go ahead and take a quick second. Does that all make sense to everybody?
That makes sense to me.
Yeah. Great. So we're going to have a lot more examples about this stuff. Again, we're just going to go over the definitions. I'm going to give you some examples, but when it comes down to it over the next couple of days, we're going to put these examples and these definitions into action so that you guys can actually see how it's working and make more sense of it. Okay, so even if it doesn't make sense now, feel free to ask the question. I don't mind repeating it 100 times if I have to. I want to make sure you guys understand it. But as we go on, there will be a lot of repetitive actions with these definitions. Okay, let's go ahead and take 5 seconds real quick and see if you guys have any questions. Feel free to chime in. All right. So with the azimuth, let's take a look at this house right here, or these roofs, and just pick out a couple of these. Okay. So this is a true satellite image of down here in southern Arizona. It's actually up in Phoenix. So let's determine a couple of azimuths with these homes together. Okay. First thing we're going to look at is some of these have panels on the north side, some have it on the east, on the west side. So let's figure out what some of these azimuths are. And all we do is we take up our compass and we take a look at north, south, east, and west. And we're gonna move this guy right over here. Actually, yeah, this is on the north side. Let me flip this real quick, guys. 1 second, because that is upside down. I don't know why that picture is upside down, but it is. All right. That's more like it. All right. So we'll pull back up our compass. North, south, east, and west is what we're looking at on these. So let's take a look at a couple of these roofs and figure out what we're looking at here. Some of these are not, I'm just going to do it live with you guys so you guys can see it. If we're looking at this guy right here, not 170. Yeah, no, they'll be right. I just got to move them. And let's take a look here. On this roof. Apologize for that confusion. Okay, so 275 and 295 and 170-degree azimuth. So if we take a look at it, just look at your map right here. It's
I don't think I can see
just
it.
below 180. So if we were going due south, we'd be at 180 right here on this house. This
Here's
house,
180.
we'd be right about here because they're slightly kicked off to the side. We're at about 185 here. This one's a little
Chris,
bit
we
170.
can't see the map.
Oh, you can't? Oh, my screen share quit. You guys
There
see
you
it
go.
now? Okay.
There it is.
All right, cool. So 275 and 95 for this roof right here. It is slightly, just barely, clicked, slightly, just barely a little bit more northwest than it is due west. Do you guys see how that one works right there? On this roof, this is slightly more southeast than it is due south, but it's about 10 degrees off. So we're looking at close to about maybe a 170 azimuth on this one. And here on this house back here, this roof is coming up to about 225. Not that roof. Where did it go? It was over here. Sorry, I had to flip the map, so it messed some of this stuff up. It was this roof. There we go. So this roof right down here is close to about a 225-degree azimuth. This roof that has solar on it, some people might ask, well, why didn't they put panels on both sides of this roof? In Arizona, the more north you get, you get a lot less production. So they put as many panels as they could facing as far east as possible, a little bit more southeast than possible. As soon as you start putting them here, you're going to start losing some production. But this system will not produce as much kilowatt hours as this system that would be sitting right over here on this 170.
Mhm.
Or this is the one right here that's also sitting on a 170. It's a much larger system. Right here, this one's facing a little bit more south. This one's not exactly 170. It's probably maybe 160. Close, we're getting closer to that 135 mark. What's happening here is that from sun to sundown until sun gets about maybe right here, closer to sunset, they're getting direct sunlight for most of the day. When the sun hits about this point, they're not really getting production on these panels from about right here. So maybe about 1, 2 o'clock, they're not getting as much production on these panels. It would have been a good idea for them to put some right here. It's still going to be, let's say that these guys needed a 12,000 kilowatt hours and they also needed 12,000 kilowatt hours. A 7 kilowatt system would suffice on this, but they would need probably closer to an 8.5 to a 9 kilowatt system to produce a 12,000 kilowatt hours that this home needs, that both the homes need. It's because the azimuth, it's because the direction of the panels and the direct sunlight that those panels are going to be gathering during the day. So this is a huge impact on the solar production itself. It's also, yes, Nathan is also related to the position on the equator. So you got a little bit ahead of me. This is smart. Good question. So I have a map I'm going to show you guys. So the position on the equator actually directly determines it, which is why when you go further north, the way the sun is, if you talk to, who were we talking to recently? They're from the island of Palau, very close to the equator, and it is just hot all day long. And the sun is actually a lot lower in the sky than it is over here in Arizona. When you start going more north of the equator, the sun looks like it's higher up in the sky. And as closer you are to the equator, it looks like it's more level in the sky. Because of that, direct sunlight directly affects it, which is going to affect the next one, which is the tilt, which we start angling some of that stuff too. So we use the azimuth and then we use the tilt for that as well. Any questions on azimuth before I jump forward to the next one? Doesn't look like it. All right. So let's look at our tilt. So the way that we tilt the panels has the biggest impact on the position of the sun. So we can gather the most amount of direct sunlight based off of the tilt of the panel. This is going to be more relative to the position of or where you are positioned on the earth because of the equator. We can make those adjustments. So the tilt of the solar panel is also known as the pitch and will impact the amount of the tilt towards the sun for the PV array. Most arrays are flush mounted, meaning they follow the same pitch as the roof, but are raised a few inches above. And this is why you see a little bit of a gap in there. If the roof is flat or nearly flat, it may be desired to tilt the solar panels on the roof to achieve the optimal angle towards the sun. So this goes back to that equator question. The position of where the sun sits in your sky, depending on where you are sitting on the earth, we can tilt the panels to be able to collect that sunlight depending on where you are. So if you take a look at this map right here, so geographic location is a major factor. Because of the earth rotates around the sun at a tilted axis, higher latitudes area farthest from the equator will yield lower levels of production. Just like it's possible to get a sunburn on a cloudy day, your solar panels can produce energy from indirect sunlight. Will it produce as much energy from indirect sunlight? Absolutely not. So let's take a look at some of these. So Alaska's obviously a lot higher north, number one. They have a lot higher altitudes. They also have a lot less sun production. So they're going to be closer down here in the blue. They're going to have some areas in the green because of the amount of sun they get, but it's still not as good as it is down here in the Southwest. All this orange all the way up until the red, we can see there's going to be a lot of production here, which means that we can probably, or we know exactly where we need to put the panels based off of this. And we have a bunch of other tools. We have Sunspot. Google has a tool now where we can see how much sunlight those panels are going to receive on that roof. And then based off of the location, we can tilt the panels to collect that optimal sunlight at the right time of the day so that they can produce the most power, have the smallest system possible to produce the most power. Okay. So let's take a look at the roof, because the roof does matter when we're determining the pitch or the tilt of the panels, because the pitch of the roof does affect it a lot. So if we're looking at a 212 is what it's always going to be by 12s. So 212 right here is almost a completely flat roof. 412 is a little bit more of a pitch. Newer home standard. So up till about 20 years ago, 412 was kind of the standard for most homes built in the Southwest. When you start looking at new homes across the country, 6 was a pretty good standard for most of the country, or most of the country in the north. Okay, so depending on the part of the country, the builder, or even a personal preference, will be different roof pitches that can directly affect the solar installation. This will directly impact the tilt of the solar panels. Conventional slope roofs are the most common with residential roofs. This means that the slope is between 412 and 912 on most homes. Roofs with a pitch exceeding 912 are called steep slope roofs. We can't even walk on them. We don't put panels on those type of roofs. So if you see like a steeple, like a church, this is something like this. It's something like this. We don't typically put panels on those. You can't even walk on them. It's unsafe. So those would need something like a structure or ground mount type system. And those are great because we can determine the pitch exactly how we want to. But if you're putting it on a 612 roof like this one right here, can we cut away a part of the roof to be able to angle it backwards to get the optimal pitch? No. So they're going to sit flush against that part of the roof. We could tilt them up a little bit, but aesthetically, a lot of customers don't like that. So we do our best on the back end to determine what's going to be the best aesthetically pleasing design for the customer, as well as the best production for the customer, so we don't have to oversize the system and charge them more money. We want to do the best thing for the customer every single time. One thing that's pretty common to see as well is called a reverse tilt. That's where the panels on this side of the roof are going to be facing straight up over the peak of the roof. This shouldn't be a very common practice. It can cause problems with wind loads, and can end up affecting the actual overall production of the system in a positive way. Doesn't look good. Some customers don't care. They don't care how it looks. They just want to get the best production. Can we do it? Yes. We're limited on how many we can do, depending on the part of the country that you're in, because wind can be a big factor when you're doing a big tilt like that, because then you have a giant exposed area back here. So there's other factors that go into it, but the biggest thing I want you guys to take out of when it comes to tilt is you're looking at on a 412, we're likely just going to sit it flat. 612, we're going to sit it flat against the roof. We're going to keep 3 to 6 inches spacing in between to allow for airflow and access to the panels. But what you won't be seeing is a lot of tilting upwards, and you definitely can't see tilting backwards. Otherwise, that means that we're taking axes to the customer's roof to be able to put them tilted backwards, which would end up causing shading anyways. It's not a good idea. So here's a good example of it. So how do we fix the production? Adjusting the tilt can help. Adjusting the tilt can help. Can't talk today, guys. Adjusting the tilt can help compensate for losses based on geographic location. By adjusting the angle of the panel, the amount of direct sunlight can be controlled. For the solar panels to get their best performance, a steep angle of 60 is best during the spring, and the best angle is going to be 45 during the summer, where the sun is at its highest peak. But it's best to have a low tilt at 20 degrees when it's at its highest peak. So again, that geographic position is going to have a big impact. So when we're looking at some of these roofs, we have to figure out, well, do we need to maybe tilt these up by 5 degrees on a 412 to be able to get the best production? We might have to. If the customer says no, we'll lay them flat. We might have to add an extra panel or two to be able to compensate for the tilt on that. It's always going to be best to have that conversation with the customer. If it comes up, you will see it in the notes. If the design team says, hey, we need to tilt it on this roof for whatever the case may be, you will know if it's going to be a tilt so that you can inform your customer that there will be a slight tilt on the actual roof itself. This is an example of a flat roof. So this is just the example of those, different degrees and what it's going to look like. Here's a direct 90-degree tilt, and we're going all the way back down, all the way to that 20-degree right here. This would be close to a 412. This would be close to a 612. This is close to one of those 912s right here. So it's like an 812, 912. Okay. As soon as we're hitting right here, this is 10 to 12 on the pitch for the roof. We're not even installing that. On a flat system or on a structure system, on a ground mount or on a structure, we can position the tilt however we need to in order to be able to capture it best. We can also place it in whatever direction that we need to, because we're not limited by the shape of the roof to be able to put the panels on there. So here's a good example of that flat roof. So if we're taking a look at it right here, you guys can see, you guys are going to understand why the spacing is there in just a minute, but you can see that we have a little bit slightly of a, probably close to about 20 degrees. So this may be close to a maybe a Florida installation or one of our Arizona installations. It doesn't need to be very steep in order to be able to collect that. So they put it, roughly about, maybe 20, 25 degree pitch on there, or tilt. This one's closer to about a 45-degree tilt. But again, it's on a seemingly flat roof. So this is probably one of those 212s. So installing solar on a flat roof requires a different type of racking system too. So what we have to do in a system like this is we're going to be spacing them at least 3 feet apart. The largest benefit to solar on a flat roof is that we can do virtually any azimuth, and we can do virtually any sized or any tilt that we need to in order to be able to capture that production. I'm going to turn on my ring light real quick. There we go. There we go. So solar panels can cast a shadow behind them because of the angle that they're tilted at. To avoid creating shading on the rest of the equipment, the correct distance between the panels is necessary. Too close in the shadow can affect the production. Too far apart, and you can reduce the number of panels that fit on the roof. So this is going to be one of those factors as well when we are doing flat roofs. It's great because we can adjust the tilt wherever we need to in order to be able to get the most production, which is always a fantastic thing. And we can adjust the azimuth because we're not restricted by the shape of the roof. So if we were to put it on here, we'd have to put it in this direction. And if, let's say this is south, this means we're probably stuck going east, and we're going to be stuck at that 612, which is, from the looks of it, it's not going to be a very good tilt to be able to capture the most sunlight. Is this making sense to everybody? Fantastic. So this is what it looks like when you're casting those shadows. This is why we have to have those separations between them. So because we're tilting those panels up, we're going to be seeing a shadow cast just like this at that angle, which can cause a loss in production. We're going to go over shading here in a few minutes, but we try to avoid that as much as possible. So we want to go as close as we possibly can to each other so we can maximize the number of panels that'll be able to fit on that roof without causing any type of shading whatsoever. Okay, so that is that. The layout will be more effective year-round. This layout will be a little bit more effective year-round. So check this out. What this installer did, they probably did it with the customer. They're like, hey, we can put them on here, and during the summer, you're going to get a ton of production here, and during the winter, you're getting a little bit more production here. The sun's going to be in the highest point, so you're going to need a little bit lower of an angle. So take a look here. In December, about the 23-degree pitch, all the way up until June at 70 degrees. So we have a very, very nice 43-degree standard, which will be good for this design right here. Depending on where they've installed this system, this is a very good design for that customer, and it looks great. This is what we're trying to accomplish when we build out these systems. Now, again, we're doing it virtually. We are sitting behind a computer screen, staring at a topographical map, and they may have made some adjustments to their house. We don't know. So you can actually talk to your customer and have these conversations with them. Do they like the layout? Do they like the position? Do they like where they're sitting? And if they do, fantastic. If they don't, well, we can have that conversation with them. And hey, what if I put them over here? Well, that's going to affect your system production. Well, why? Well, because of the design, because of the tilt and the azimuth, right? If we put it on your shed over there, your shed's facing north, the back half of it has a whole bunch of pipes sticking out of it. We can't put any panels on there, and the north facing panels aren't going to be collecting as much sunlight as they were if they were facing south. So putting it directly on the roof is going to be the absolute best thing that we can do for your production to lower your electric bill. We'd have to put double the size system on a north facing roof to get the same amount of electricity because of the azimuth and because of the tilt, which is why we designed it this way. So this is why you guys need to know this. You guys can have these conversations, right? So just like we were talking about before, when it comes to referrals, when it comes to talking to the neighbors, we don't know all these situations before we get in there. All we know is that they want to get panels on the roof, number one, and number two, we're designing it from afar. Once we get in, we design it this way. They're going to have some questions on it. We designed it based off the best tilt for the position, where they're at in the world, where they're at in the country. We designed it based off of the roof, what's going to be most aesthetically pleasing for the customer, but is not going to reduce their production or cost them more money. I talked pretty fast for that one. I know you guys probably have some questions. Let's go ahead and do that, and then we're going to take a break in about 10 minutes. We're going to start the next module and then take a break. So go ahead and start asking some questions.
Yeah, I just want to clarify, make sure I understood it correctly.
Yeah.
So what really affects the system is where they are, I guess, kind of on the equator, and also the direction the roof is facing. Those would be some of the biggest factors, right?
Some of the biggest factors. It's like down here in Arizona, we have a lot of flat roofs, so those are great. We can do whatever we need to. So the tilt's going to be based off of the position of the sun in the sky, which is based off of where you're located to the equator, right? The azimuth is going to be based off of the direction that's going to best suit the production. Where are you going to get the most sunlight? So both those have a big impact on each other. If we don't have a good azimuth and we don't have a good tilt, it could cause an issue, and it may actually disqualify a home from even getting solar.
Thank you.
Anybody else? No? All right, we're gonna do a 15-minute break. Let me see what section we're next. Yeah, shading's a good one. I don't want to take a break during shading, so why don't we go ahead and take a 15-minute break now? And we'll come back and we'll go over shading at 7 o'clock.
It's been 2 hours now? Hour and a half?
Yeah, so let's do 7 o'clock, 17 minutes. Go and take a break, stretch your legs, go to the bathroom, get something to drink, and I'll see you back in a few minutes. Okay, guys?
Awesome. Thank you.
Thanks, Chris.
Of course.
My name is Jorge Orozco with Team 7 here at Titan Solar Power. Today we're doing a 44 panel install. We're installing 340 sill fans. We're doing a couple arrays. It's a flat roof, so there's a couple of different things we have to do today. Got done landing panels, got everything done, everything's tested well. So I'm gonna go ahead and I'm gonna turn this bad boy on and make sure that this system's ready to go. Jorge Orozco with Team 7 here at Titan Solar Power. Today we're doing a 44 panel install. We're installing 340 sill fans. We're doing a couple arrays. It's a flat roof, so there's a couple different things we have to do today. Got done landing panels, got everything done, everything's tested well. So I'm gonna go ahead and I'm gonna turn this bad boy on and make sure that this system's ready to go. Jorge Orozco with Team 7 here at Titan Solar Power. Today we're doing a 44 panel install. We're installing 340 sill fans. We're doing a couple arrays. It's a flat roof, so there's a couple different things we have to do today. got done landing panels. Got everything done. Everything's tested well. So I'm gonna go ahead and I'm gonna turn this bad boy on and make sure that this system's ready to go. With Team 7 here at Titan Solar Power. Today we're doing a 44 panel install. We're installing 340 sill fans. We're doing a couple arrays. It's a flat roof, so there's a couple of different things we have to do today. Got done landing panels. Got everything done. Everything's tested well. So I'm gonna go ahead and I'm gonna turn this bad boy on and make sure that this system's ready to go. Jorge Orozco with Team 7 here at Titan Solar Power. Today we're doing a 44 panel install. We're installing 340 sill fans. We're doing a couple arrays. It's a flat roof, so there's a couple different things we have to do today.
All right, and I am back, guys. Everybody do a quick sound off, just unmute and say you're back when you're back.
I'm back.
All right, 1,
We are back.
2, 3.
I'm back.
4. We'll get started. Everybody else can catch up when we're in. All right, so before we jump to this next section, I just want to take just a few seconds. Maybe you thought of some questions. Maybe you have a question and you're embarrassed to ask it, guys. It's absolutely okay to have these questions. Remember, if you have it, somebody else probably has the same question you are, but they're embarrassed to ask it. So do not be afraid to jump in. There's no such thing as stupid questions. I asked plenty of them. I call some of the smartest people in the world and I ask them the dumbest things. And the reason why I know what I know is because I have no shame. If I don't know it, I don't know. Repeat it. Tell me again. Tell me a better way. I need to understand this. Like I was just having a conversation with Brian a minute ago. I understand that there's things that I understand personally, and I may not explain them the right way to you guys that you understand it. We all understand at different levels. So feel free, hop in, ask any questions. Real quick, just to open it up, a question I typically get is like, all right, so, and you guys are going to hear this a lot on the doors. So like I've gone over multiple times, why is my system size different? Why do I need more power? Why is this? Why is that? When it comes to my system size and my neighbor's system size, we have the similar bills. We have the same amount of people. The other one is, hey, we both have 5 people in our house. Why is my bill double and theirs isn't? Well, your usage, your consumption is probably different. You don't have the same appliances. You don't have the same needs. You don't plug the same electronics into the wall. You don't, it's weird. My light just went out. You don't plug the same appliances into the wall. You don't have the same activities. You may be less cautious. You may like your house a lot colder than they do. So you run it more. You may run more heat during the summer. There's a lot of different factors that are involved in this stuff. So that's usually a big aspect to it is why, sorry guys, my light keeps going out. Why is my system size different than everybody else's? Well, it could be that. It could be that you use more power. One of the other reasons why could be because the tilt. It could be because the azimuth. It could be the position of the roof. It could be they have a flat roof. So you have the same bill, but you're on a pitched roof. They're on a flat roof. You're on a east to west facing, and they're on a south facing. And it requires less panels to create the same amount of power. So when we go over it, there's going to be after shading. There's a really cool little demonstration about how we size the system and get the peak sunlight hours, and I have examples so that you guys can see it, and probably put a couple extra examples together live with you, like on Word or something, so you guys can see how that's working out. So again, if you have a question, if it's about electricity, if it's about math, if it's about that stuff, hop in now before we get started. And if you work up the courage and you had it later, just interrupt me. Shoot it in the chat directly to me so nobody can see it was you. That's another way you can do it. If you have a question, if you click on the chat box, you drop down for everybody, you just put it straight to you put it under me. then I can see your chat. Nobody else can. So feel free to ask ask questions that way too if you need to. I keep that up and open so I can see it.
I did have a quick question. So in Phoenix, if I'm selling there, would everyone have the same azimuth?
Same tilt, yes. Same azimuth, no. So azimuth is going to be based directly on the position of the roof, right? So let's go back to our map. Here it is. So let's take a look at the map. So the azimuth, this is going to be slightly different. Okay. So the azimuth is going to be that compass, the north, south, east, west, and everything in between. So the azimuth is going to be rated in Phoenix. 180 is a great azimuth from sun up to sundown. Those panels are going to get direct sunlight. As the sun's at its highest peak on this roof, the panels are going to be sloped at a 45-degree angle typically. These look like they're about 45 degrees on a 612 facing east. They're not getting as much direct sunlight as these panels would be, right? But from 9 a.m. or from 7 a.m. to about noon, these east facing panels right here are going to get more more direct sunlight. If they put some here for the rest of the day, are you still going to get a little bit of production because light's out? Yes. Are you going to get as much direct sunlight? No. So you're not going to get as much production. But here on this side of the roof, you're going to have more direct sunlight facing here and hitting here, which means you're going to get more production depending on the different time of the day. Does that make sense?
Yes, thank you.
Okay. Yeah, tilt and azimuth, they get confused a lot. So, if we need to give other examples, let's start getting those out now. And we will run through the stuff again. All right. Cool. Shading. Let's do this. Let's get excited about this. Shading. Shading is, we started learning a little bit about this in the last part of the module. We were talking about how the panels could actually shade each other on a flat roof because of the tilt of the panels. We usually space them about 3 feet apart, depending again on, the tilt is all affected by where you are at according to the equator, right? So it may not need to be 3 feet in all areas. Average is about 3. Just keep that in mind. If you're in a different territory, I think further north, we can, sometimes it might have to be 3.5, but a good average is about 3 feet apart. We're going to determine that during the site survey, and we're going to check it during installation to make sure that there are no issues there as well. We check these things many, 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 many times, all the way up until the day of installation. And we're testing them after they're installed to make sure that there's no issues. This is why we have warranties. So we can make sure that on workmanship warranties, to make sure that we did the best for the customer that we possibly could, and they can hold us to it. So shading is one of those factors as well. Shading can be caused by something as small as a ventilation pipe coming out of the roof, as big as a chimney, or an entire tree. Sometimes it's the neighbor's house. If you take a look at some of the neighborhoods around here, or anywhere that you go, you can see a single-story house and directly in between 2 two-story houses. That can cause some major shading issues because from certain points of the day, that roof is going to, or the 2-story house is going to be shading the roof of the single-story house. 1 second, guys.
Do you have an extra nut?
So because of those types of situations, we have to take into account for this. So on our proposal tools, we actually have, we can see what's on the top of the roof and start to make accommodations for those. If they have a parapet, if they have retainer walls, if they have vents, if they have what are they called? Skylights. All these things are factors when we're building out the system. because it can directly affect the actual production of the system itself. So solar panel shading is simply this. This is what it's defined as. Shading a solar cell is similar to introducing a clog into a pipe of water. A clog in a pipe restricts the flow of water through the entire pipe. Similarly, when a solar cell is shaded, the current, remember that's the flow, guys, the current through the entire string is reduced. So when we see shading, the entire string gets reduced on this panel, which will drop the production of the panel. It can drop it as much as 30 to 40% just off of a little small corner of the panel. The part of the panel that's shaded is now basically like having a kink in your hose. Whatever's coming out of the end, or the ultimate wattage that the panel's producing, is affected by that one part of the solar cell being shaded. This is why it's so important that we take these factors into consideration. So think about it, we've all had clogged pipes before, right? If you think about the drain itself, the water going into the drain is affected by whatever's clogging up that pipe. So when we put these things together, this is why understanding current was a little bit was important. Understanding the wattage, the current affects the wattage output a lot. If you start clogging it up, if you have a lot of resistance inside of that circuit, you're not going to be pushing out as much wattage at the end, which means that you can actually decrease the amount of production that you have in your system. So it looks like this. So partially solar panel shading, partial solar panel shading. One of the many factors that is directly responsible for the degradation of output power is partial shading. Partial shaded cells produce less current than other normal cells that are exposed to direct sunlight and behave in a reverse bias p-n junction. As a result, this dissipates the power instead of generating it and gets heated up. So if you start, we had an example earlier, if you kink a hose for too long and you have a lot of pressure behind it, so what's going to end up happening to that pipe? It's going to burst, okay? Mm-hmm. The same type of things can happen because you're reducing the current, but the flow is actually starting to back it up. That can cause heating, which will ultimately also help decrease the production. So we have to take a look at all these factors when they're putting in, because even a partial shaded cell can actually start degrading the panel even more. So solar degradation is another factor when it comes to solar. When it comes to solar panels, actually all electronics, anything that you use. Are your shoes as nice as they were when you first bought them? No, they are scuffed up now. They're, they have marks on them. There's chunks taken out of the sole. They're not as comfortable. Take a look at your cell phone. Let's go with the actual electronical usage, right? Your cell phone doesn't hold the same charge it does at the day you bought it. It's not, the screen isn't as bright as the day you bought it. The camera doesn't work as well as the day you bought it. Everything degrades over time. When you start partially shading panels and solar cells, what ends up happening is this exactly. You start actually increasing the degradation of these panels, which can actually cause more problems. Degradation for most panels, for tier 1 panels, which is what we use here at Solar Panel Pro. Well, I have to change that now. At Titan Solar Power Pro, Titan SPP. What we look at is panels that reduce about 0.05 to 0.06% on an annual basis. If you have partially shaded cells and they're causing the panels to get heated up and they're causing more degradation, those panels can die a lot faster than panels that don't have this type of disruption in their current, in their flow. So you can see it right here on this graph. This is what's happening, the actual output and the voltage in the system itself. It starts to drop, and then by the time it gets to the end of its circuit, you drop the voltage completely down to 0. That's not where you want to be. This can cause issues through the entire string. So unshaded cells are 100% current and 100% voltage output, which gives you your wattage at 100%. Partially shaded can be up to 30 to 40%. So output current directly proportional to the illuminated area of the cell. No voltage change. This is why it gets heated up. The voltage doesn't change but there's a clog in the pipe. So you're pushing all this stuff through and you have a very little hose. So it turns into kind of like that little water gun, that analogy that we're using earlier. You have a very small pipe and you're trying to push a whole bunch of stuff through. It's going to end up causing problems with the other cells that are being shaded and could end up destroying those cells. And a completely shaded cell has no output whatsoever. So it operates just like sun going down. There's no sun, there's no power. So just like it says here, a shaded solar panel will not function. It's the same as no sun on a cloudy day or night. Let's take that quick break here to ask some questions. What do you guys have question-wise about that? Because I know degradation isn't on there, but it's a really simple term to know. So degradation rate is the rate at which a panel loses production over time. Same way your phone does, same way your clothes do. They start looking dingier the more they go in the wash. The more you use something, the less of the original production and the rest of the original value that it had. It starts to decrease over time.
And you said that was 0.05, 0.06 per year as a standard?
On tier 1 panels, yes. It's also the type of cells too. And I'm going to show you guys the different types of cells and kind of what those outputs look like on those. Any other questions about those? All right. Solar cells, guys. So solar cells, there are different types of solar cells. I'm going to give you guys a long version with a lot of information about it. And then I'm going to boil it down to a couple sentences that will help you understand it and help you explain it to your customers. One thing we like to do here is we do teach all of our homeowners how to read these things and what it means. One of the sales practices that we do is we give them a definition for something early on, and then we ask them what they would rather prefer, because then they have the knowledge and the information to properly answer that question. It helps with a lot of those objections. I need to think about it. I need to do research. We're going to be their research. We're going to be their encyclopedia. This will always be accessible to you to go back and look at. There's going to be a public version of it for you to send your homeowners to, so that they can go back and hear the different terms and understand all these different terms and how they affect solar, so that they don't have to take your word for it. They can hear it directly from the horse's mouth. And I did call myself a horse. Solar cells. Different types of solar cells. Monocrystalline solar panels are a single cell panel. Each solar PV cell is made up of a single silicon crystal. These sometimes referred to as monosolar panels. Polycrystalline solar panels. Each PV cell is made up of multiple silicon crystal fragments that are melded together during the manufacturing process. You may see these called multicrystalline or polycrystalline panels. So there's one of the broad definitions. Let's bring it down. Mono means one, poly means many. So if you need to try to remember which does which, mono is one, poly is many. So because we have a single monocrystalline cells, we have a single cell, it's a more efficient cell. These are typically what we use. These are all we use. We do have access to some of these polycrystalline panels, and you guys will understand a little bit more about those. They do function the same way. What it's doing is grabbing the photons, photovoltaic, right? Grabbing the photons, you have your glass transparent on the panel, and then you have your actual conductors here. That's going to be producing the negative current and the positive current, which is going to ultimately give you your wattage at your electrical device. This is how a solar panel works right here. Okay, the glass on top, and then you have your actual your layers in here with all of your with all the cells, all the photons being collected by the solar cell. And depending on what type it is, can affect the ultimate output as well. So monocrystalline solar panels are characterized by their black PV cells with rounded edges. They have a higher conversion efficiency than polycrystalline panels, which means they produce more kilowatt hours of electricity. If you want to install solar panel system, but your space is limited, monocrystalline panels will be more productive per square foot. While they're the more efficient panel, they are sometimes more expensive because of this reason. The manufacturing process for a single crystalline cell is a lot more complex, so it's more expensive. Yeah, I'll tell you guys that here in a minute. But as you can see, this, just like I was showing up there, it transfers it from the positive to the negative. You're creating energy, so it's going that way. You're not using it to where it's going the opposite way, which we learned earlier with voltage, right? So polycrystalline panels are a little bit different. Polycrystalline panels have that blue hue. So up until about 3 years ago, we saw these as a standard on most roofs that you saw with solar. They had blue panels on them, not black. So you can see that the industry has made a big shift in how they're putting up panels. Most people are using monocrystalline. Yes, they're more expensive because of the manufacturing process and they produce more power, but they're better equipment, especially in higher heat areas. So polycrystalline panels have the blue hued PV cells with straight edges. They have a lower efficiency compared to the monocrystalline panels, which means that you need more panels to reach the same power output. However, polycrystalline panels have a lower price since the manufacturing process is much simpler. Polycrystalline panels are very durable, but they do tend to last slightly less than monocrystalline panels. They are more affected by the high temperatures, which reduce their productivity on the hottest days. So if you're in one of the markets where, like say Southern California, where it can get up to 100 degrees, Arizona, Texas, New Mexico, Florida, some places pretty much all along the South, and you reach temperatures at 100 plus, on those hot days when you need more demand for your utility and you're trying to offset that with your solar production, your production is now reduced because as these heat up, it's going to drop the production. So that's where we talk about the heat coefficient and how that matters with solar system. So a couple of key differences between those before we get into that. Monocrystalline panels have a higher cost when comparing to the other panels, The cost of the inverters, wiring, electrical protections, racking, the labor, it's all the same. You can put them all in the same type of racking and use it with the same inverter. Because polycrystalline panels are more efficient, you get better return on your investment, and homeowners are eligible for the federal tax credit where they choose to go mono or poly. It does not affect it. The reason why that's in there is because there has been some smaller companies who've been trying to get a foothold who do say the opposite. You have to have one type of panel. You don't. As long as you have a solar system and it's installed, you are eligible to get the tax credits. Doesn't mean you get it. No, you're eligible. We'll learn more about that on Thursday. So here are those major factors and differences. So the silicon arrangement is the pure silicon crystal. It's a single cell. And then you got mini for the polycrystalline. The cost is more expensive compared to the poly. They're black instead of blue. They're more efficient. They can last 25 to 40 years compared to 20 to 35 years. And they have a lower temperature coefficient, making them more efficient in the heat. And polycrystallines have a high temperature coefficient, making them less efficient in the heat. So if you're in a high heat area, you're going to want a monocrystalline panel either way. If you're in a low heat area, you're still going to want a monocrystalline panel either way. If you're in freezing cold temperatures, you're still going to want a monocrystalline panel. The reason why polycrystalline panels are still sold and they're used as a standard for most companies is because they're buying these things from distribution companies and because they don't have the volume to be able to go direct to the manufacturers. So because of our relationships with Titan and because of Titan's relationships and their buying power to go directly to the manufacturers, we can actually offer basically, and a lot of times, less expensive systems with better tiered equipment. We're seeing an average of about 20 cents per watt less expensive than every single one of our competitors on the market because of the buying power that's standing behind us, because of our relationships that we had. We can price our systems better than the competition and provide them tier one equipment. So it's basically like giving a customer a BMW for the price of a Honda. And that's what we do here. But we're not giving them a Honda, we're giving them that Beamer. So polycrystalline panels, you'll see these used a lot. A very common one is REC. Does this mean that they're bad panels? Absolutely not. They are great panels. They do last 25 to 30 years. They do have 25-year warranties on them. They do produce, but the temperature coefficient has a big factor in those. They can cause problems when it starts to heat up in certain areas. So when it comes down to it, which would you rather prefer having, a monocrystalline panel or a polycrystalline panel? Or would you rather have a mono or a poly? Do you want the black ones or the blue ones, right? We can have these conversations with the customers and explain it. You just have this, right? So here's how the heat coefficient works. So monocrystalline solar panels have a higher efficiency. However, it doesn't mean that polycrystalline panels are inferior products. You can find high quality solar panels for both types. Here are a few factors about the efficiency. When a solar panel has higher efficiency, it converts a larger percentage of the sunlight into electricity. As of 2021, polycrystalline panels are typically have typical efficiencies below 20%. And the monocrystalline panels are approaching 23%. So right now, as you're looking at the REC, right, they have a mono poly blend panel. Half of it's polycrystalline, half of it's monocrystalline. There are some pros and cons to it. When it boils down to it, it's less expensive, but they're averaging about 19 to 20% efficiency. The monocrystalline panels have a 23% efficiency. The panels that we use on standard, the Q cells, no longer LG because they're out of the market. They are no longer producing solar panels. The Q cells, the SILFABs, these have a 22 to a 23% efficiency rating on their panels, which means that they're going to convert more of that sunlight to create more power. Okay, this is how you get higher wattage panels with the same size footprint as these other panels. You'll need more polycrystalline panels to reach the certain kilowatt hour output per month since their efficiency is lower. So even if you have, real quick, 1 second. Yes, so that's a good point. So this also affected on the actual square footage. So I have a 450 watt panel. Why is it so much bigger than the 400 watt panel? Well, you need to fit more cells into the panel to be able to fix it. Does that mean that's more efficient? No. Okay, so just because there's more wattage, does that affect the efficiency? The answer is absolutely not. It means that you're going to be able to use less panels to create the same amount of wattage, but they are starting to get a lot bigger. So you're seeing some of these 450 and 500 watt panels at 5 feet high, 6 feet high, 3 feet wide. So you start actually reducing the square footage as you start going up into those, just so you can have that higher wattage. It's not really comparable. So having a decent sized panel, decent sized weight with the same efficiency on a lower footprint, you're going to end up getting a few square footage difference, but nothing crazy. Okay. I think that's kind of what he was going for with that. So, but yeah, you guys will hear that too. You guys will get that question. They're offering me a 450 watt panel. That's fantastic. So all it means is we need to put a couple extra panels to be able to reach that because we're using 400 as a standard. Let's look at the pricing, right? So they might be offering a larger wattage panel, but they're probably more expensive too because they don't have the same buying power behind it because they're a smaller company. Just wait till you start seeing that stuff. Perfect. So all solar panels suffer temporary efficiency drop when the temperature increases, but monocrystalline solar cells are less affected by the heat. So like we were saying earlier, if you're in a hotter temperature area, you're going to want a monocrystalline panel or a poly? You're going to want a mono. Does that mean that they're unaffected? No, they are affected less. So you will see a drop in production. So these are other factors that we put in depending on the area. This is why it's important, and this is why we do all the proposals. We don't give sales reps an opportunity to be able to build these proposals because we create that standard from the very beginning and put it on the back end. If you ever have a question, get the proposal, and we can engineer the expert to detail and compare. So yeah, so if they have questions about it, we'll pull their proposals that they get from the other customers, and we'll actually compare it side by side. You can send in their proposals to us, and we can actually see what they did and why they did it. We can explain it to you so you can explain it to the customer. You guys are seeing a lot of different type of proposals, and we want to teach them how to read them all in general. So these factors are all going to come into play as you start to learn more about how these work. If you get a customer that wants to prepare proposals and you haven't done it long enough, a manager will help you do that. We definitely want to be comparing those proposals so we can understand, so they can understand why they're being charged what they are, why the system is being built the way it is. We do it on the back end so that we can create a standard for the customer and make it a very simple and clean process for them. So the temperature coefficient indicates how much solar panels are affected by temperature. All solar panels are factory tested under the same test conditions to ensure fair comparisons. In general, polycrystalline solar panels tend to have a higher temperature coefficients, which means that they lose more productivity when they're heated up. However, as technology improves, there are now solar panels of both types with similarly low temperature coefficients. So that's what we're talking about, like those RECs. Are they bad panels? No, they are not bad panels. They're actually pretty good panels. Are there better ones out there? Absolutely. RECs are still not considered tier 1 for multiple reasons. And one of those reasons is because they are generally poly panels. They do have monocrystalline panels as well, but they're a lot more expensive to get them from REC because they are generally, they generally use the monopoly blend. So solar panel efficiency is not a critical factor when you have plenty of space available. Since polycrystalline panels have a lower price, installing more to compensate for the lower efficiency is not a problem. However, if you have limited space, installing the panels is not an option. So monocrystalline panels will maximize electricity production in the available area. So think about it this way too. If we're looking at a system that they both need to get to 8 kilowatts, they're going to be adding more panels, which will sometimes end up being the same price as having a mono panel anyways. So we can drop the square footage that's being used and be able to offer them a better looking panel, better wattage, better efficiencies, better heat coefficiencies, and better production in general. So this is why we use those. So lifespan and appearance and performance, we've already gone over it. Typically, you're looking at about 25 to 30 year warranties on a lot of these panels. It's standard 25 years on all solar panels right about now. The appearance of the solar cells also is the result of the silicon structure, since it determines how they interact with the sunlight and how they are perceived by the human eye. A single crystalline structure of monocrystalline cell gives a black color, while polycrystalline cells are blue. Both solar panels types have long lifespans, and their payback period is less than 5 years in most cases. Solar manufacturers normally offer 25-year production warranty, power production warranty, but some brands now offer up to 30-year warranty coverage. So the power production warranty that's offered by a manufacturer is going to be off that degradation rate, and if the panel is degrading at more than it should, at more than what their specified amount is, which could be 0.05 or 0.06% on an annual basis, if they start seeing a degradation rate at 0.08 or 0.10, that panel's dying somehow. That needs to be determined what's going on. The installer is going to take a look at it. We can see it through the production on the panel. We can see that that's not at that peak performance. We can determine, is there a shading issue? Is it causing damage to the panel, or is the panel out bad and it doesn't need to be replaced? So that's what the power production warranty is on the 25 years for consumers. It protects against one second. Right. It protects against the actual degradation of the system itself. So we're also looking at the production. So we're also looking at the actual workmanship warranty. Most companies offer between 10 and 15 years, some of them up to 20. We offer a 25-year production warranty because that also is directly workmanship warranty, because that also means, did we install the panels correctly? Number one, are there roof leak penetrations? Did we fix everything we were supposed to? And it goes back to, is the cell degrading because of work that was performed at the time? So we are offering an additional warranty to ensure that on top of that, to make sure that we didn't cause any damage to the panel that would cause it to go out. When we're talking about these 25-year warranties on a lot of these panels, one thing that's good to understand is that it's a lot like your phone. If you were to throw your phone against the wall, that's covered under insurance. If you were to just be looking at your phone, screen goes black and it never turns back on, that's covered under warranty. this is covered under warranty, right? So when we're looking at these things, we got to look at, is it going to be covered under warranty or is it going to be covered under production? So when we're looking at some of these warranties, we're looking at like a, workmanship warranty that may be only 10 years. They're going to rope it all under the power production warranty that comes with the panels, and they're going to explain it completely wrong. They are two completely different warranties. We have the workmanship warranty, which covers the work that was done on the roof to install the equipment, and you have the actual equipment itself. Did the phone stop working? Was it caused because you took a hammer to it? Did you throw it to a wall? Or did it stop working because of a manufacturer defect? Or did it stop working because of something that happened during installation? These are all factors that we have to take a look at when we're taking a look at these things to swap out panels, so that the customer doesn't have to, take an insurance claim to have it paid for or pay for one out of pocket itself. These are huge factors that come into play. So good way to explain it to your customers, like, look, here's the deal. If your panels start degrading, if they aren't working like they're supposed to over the course of the next 25 years, the manufacturer is going to cover it and replace that panel for you at no cost. And Titan's going to come out and replace that panel at no cost. So what ends up happening is that if you end up going on your roof and you take a hammer to your panel because you want a new one, you're not paying for it. If the neighbor kids are shooting BBs and they end up breaking a panel, which they should just bounce right off, but just in case it happens, or they start throwing rocks at your house, that's covered under insurance. That's not covered under your warranty. So I'm getting messages because yes, this is good. So yeah, we have seen a lot of sales reps out there misrepresenting them. So if you guys do have any questions, make sure you call your managers, because we know pretty much every single one of these companies' warranties, what they offer and why they offer them and how they offer them, what the actual termination clauses are, what they wouldn't cover the warranties under. So if you see a warranty that's being covered and you're competing against it and you don't know what it means, don't lie, don't make something up, don't misrepresent it just like they did to their customer. Call us and we'll give you the proper information for the customer. Okay. So, one of the things you want to look at when you're looking at these panels, do you want it in a specific color? Do you want it black or blue? So monocrystalline or black, polycrystalline or blue, right? There are people who want to buy it based off of, I want a blue panel. Okay, great. You like blue. We can put it up there. It's a polycrystalline panel. So it's not our standard equipment, so we're going to have to do it. So if in doubt, always ask for the bid and we will get an expert to look at it. So yeah, guys, if you are ever in doubt, if you're looking at these things, just get a copy of it, send a picture to your manager. We'll take a look at it and we'll let you know what to say. Okay. So if you find, you may find that polycrystalline panels produce about 300 watts and an equally sized monocrystalline panel can produce 350 watts. That's what we're talking about, those efficiencies with the cell itself. If you have space for 20 of them, you'll reach a 7 kilowatt monocrystalline panel, but it's only 6 kilowatt polycrystalline with 20 panels. Okay, so again, what we're looking at, if you have 20 polycrystalline panels at 350, monocrystalline panels at 50 watts, you're at 7 kilowatts system size. If you have 20 300 watt panels, you're at a 6 kilowatt polycrystalline size. Okay, polycrystalline system size. It's a lot of information. Let's start for some questions real quick before I move on to the next slide. Actually, I think it's the last slide. Yep. What question? None. Perfect. Everybody understand the warranties? See some thumbs up?
Yes, that was just kind of the question that I had. So that they're saying that they're warranted up to 30 years, 25 to 30. So what happens if our client needs to replace their roof? Are they gonna have to call the solar company to have them remove them and put them back on?
Yes.
Okay.
So there is a charge for that as well. It's dependent on location and a lot of other factors, but typically it's between $80 to $150 per panel to remove them and store them during the roof replacement process.
Okay. Yeah, that's all I was wondering. Just because if they replace the roof and then they, 10 years in, or because roofs are usually 20 to 30 years,
Right. No, and those are, yeah, definitely. So it's between $80 to $150 per panel. But when they put them back up, they do put new conduit, they do put new wiring and stuff like that. So the only thing that's being reused is the inverters and the panels and the racking. So the roof can come right off. They can replace the whole thing or do their patches. One of the things we do during the site survey is take a look at the actual roof itself. If they see any weak spots, if they see something that's going to be like, hey, this isn't immediate, we're going to let the customer know. We will not do work on this roof until it gets done. It is unsafe for our workers, and we don't want to come back and have to remove these panels in a year and charge you an extra $1,500 to remove these. It's not fair to you. It's not fair to anybody involved in the process. Let's get the roof done now. So we have ways to work around that as well. If a customer says they need to fix their roof, we're still going to deliver the proposal, and your manager can help them figure out the rest of it. Okay? It's like, oh yeah, I want to wait till my roof gets done. Great. We have ways we can help you do that. We do have a lot of partnerships, and we do have, I've personally been a part of one where the customer, and it was with Titan, the customer needed a roof. They had a roof quote at $19,000, and our roofers were able to get it done for $7,000. It was great. Super simple. The customer was happy. We put it in the finance, and they weren't able to write that part of it off because it was the roof. It wasn't for solar. So the loan amount was a little bit different on their ITC, which affected their buyback, or their tax credit that they got back. But they got the tax credit for the full solar. They just didn't get it for the roof replacement. But the customer was happy because they got a 25-year loan for the roof that they were having trouble paying for, and they got solar. So they were pretty happy.
Cool.
Any other questions about that stuff?
I'm good. I don't know if anybody else does, but thank you.
Yeah. So something else with the workmanship warranty, just so you guys know. Titan there's a reason why we love Titan. We've always talked them up for a very specific reason. I worked with them for a long time with my old company before I sold it, and we started this one back up. And it was because they've always taken care of their customers, and their workmanship warranty, they actually do stand by it. If there is a roof penetration that caused a leak, they're going to pay for it to get fixed. If something happens, a roofer's going to come out. Customer's usually going to call a roofer. They're going to come out, take a look, and say, hey, it looks like it was due to the installation of the solar panels. It hasn't happened very often, but here's why we're the best. It's not because we're perfect and we don't make mistakes. There's always room for human error, right? And I tell this to all of my customers because it is the God's honest truth. I am human. I am going to make a mistake from time to time. The difference with us and what makes us the best and why everybody loves us so much is because we're going to be honest about it. And if we make a mistake, we're going to fix it. And because we understand that we're human, we put contingencies in place to make sure that we reduce those as much as humanly possible. Again, that human word is in there. So just rest assured that, we're going to make sure that nothing goes wrong. But if it does, we got your back. We got the warranties on paper for you to throw it in our faces. We're gonna get it done. Okay. Let's see, any other questions? Doesn't look like it. All right. So we got about 18 minutes. Let's get through the inverters, and then we'll pick up tomorrow. Okay. So inverters is a big, important one that you guys are going to need to know about. There's a couple of different definitions in here that you guys are going to need to write down. Again, I will have a cheat sheet for you guys. It will be available in the document library. Should be uploaded tomorrow. And just so you guys know, it looks like, let me double check. I got a message that the site should be up and running. Sweet. It was up and running and crashed again. Never mind. We're going to work through it. We're going to get it back up tonight so you guys can get back in the document library. The app will be up and running on Friday. We're actually, it's already up and running. People are already using it. But you guys will always have access to that. So if for some reason you can't reach your document library on the website, you will have it in the app to be able to reach it there. The reason why we do the website is because you have access to download that to your computer and not store junk in your phone. But it is good to have some of these things in your phone. You may not need all of them there, but some of them are good. That way you have access when you're in the field to be able to read that stuff. So make sure to take advantage of both places. You guys will get those logins in a couple of days. So inverters. So a couple of the inverters that we're going to learn about today are the string inverter and the micro inverter. Okay, there's one other one. I'm going to save it till the very end. So solar inverters are one of the core functions. They convert the direct current solar panels generate into alternating current, which is the type of electricity that's used for your home. A string inverter is also called a central inverter. It's a standalone box that is typically installed close to the main service panel and the electricity meter. In some territories, it might be as close as 5 feet. In other territories, it's as far as 15 feet. The standard is about 10 feet. So we want it within 10 feet of the actual utility, of the utility box itself and the utility meter. There are typically only one string inverter or possibly 2 string inverters on each residential solar installation. It really depends on the overall solar power system size. So we're going to look at the actual system size, and we're going to take a look at the inverter. We're going to size the inverter appropriate to that system. Most cases, they can have 155% overage on them. So if you have a 7,600 watt inverter, you're looking at times 1.55. You can go up to an 11.7 kilowatt system on that roof. So if we have a 10 kilowatt system, we put a 7,600 inverter on there. There's not much room to be able to expand that system in the future. So a string inverter functions in a series circuit, with there only being 6 to 12 individual solar panels, and each is known as a series string. It's also known as an array. All right, guys, this is important to know, and we have really simple ways of explaining this to you, okay? This is important because it's how you explain it to your customers. When they work in a series, it works a lot like the old Christmas lights. Most of us are old enough to understand. Some of you guys, I don't know if you guys remember this stuff, but parents going out there, going to plug in the Christmas lights, and half of them not working. Why does that happen? They're ran in series, which means if one of the bulbs goes out, that circuit is broken, the rest of the lights don't, there's no circuit going through, which means the lights aren't lighting up. Now you have to go through and unplug every single one, put a new one in, and find out which bulb burned out to be able to get that string to work again. A string inverter works no differently. So you build these systems, they can go up to 6 to 12 panels in an array. So if you have a 24 panel system, you're looking at probably 2 arrays. This can have a huge impact on your system. If one panel gets shaded, it affects the rest of the string. So remember, we're talking about current, right? Current's the flow through the circuit itself. Now, if we take the information from the shading that we got, if one of the panels gets shaded and it reduces the efficiency of that panel by 30 to 60%, what's going to happen to the rest of the panels in that string? They're all going to go down in production. The wattage at the very end is going to go down. Same thing happens if one of the panels stops working. If there's a warranty issue on that panel and it stops working, that entire string now has a burnt out light bulb. That burnt out light bulb is going to affect the actual current in the circuit, which means that the current stops. There's no production on that entire array. So the good news about having a string inverter system is they're easy to troubleshoot. So the main advantage of a string inverter system is that you only need one of them connect to the DC electricity from the solar array to get AC power. If anything is to fail in the solar system, it's likely to be the inverter, making the troubleshooting really easy to figure out what went wrong, and they can just replace the inverter. Another pro is the cost is a lot less expensive. Installing a string inverter on a solar panel installation is cheaper than installing microinverters. Less labor hours are required, and string inverters are more affordable than microinverters. Lower probability of a wiring mishap is huge. There's less connections between solar panels and the string inverter. Therefore, there's a reduced chance that a string inverter setup could be improperly cabled compared to a microinverter system. This is important. A microinverter system we're going to learn about in a second. I'll go back and tell you guys why that is so crazy. Cons. Complicated with the rapid shutdown requirements in most territories, most of them, and this is almost all of them nowadays, there's a rapid shutdown requirement for fire and electrical concerns. It's also to adhere by utility compliance to make sure that if there is a blackout and there's a problem with it, the system can be shut down at a flip of a switch. If you're in one of those areas, if you have a string inverter system, they don't adhere to that, they don't have a rapid shutdown, you're going to end up spending more money to be able to install the rapid shutdown in that system. A rapid shutdown will need to be installed near the electrical service entrance, and connect wires and control wires will need to be routed between the string inverter and the electrical panels. It helps prevent from surges and other problems when it comes to fire problems, okay? Since there's electricity flowing from your panels and within the string inverter itself, the inverter will be disconnected at both of these two different places. Since the cost of adding rapid shutdown requirements for your solar industry is not negligible, it's important to check with your local codes and ask your installer which of these inverter systems makes more sense for you. Okay, so this is where you guys are going to come in, and you may be looking at a string inverter system. It is very rare you're going to be looking at string inverter systems by themselves. They aren't very typical anymore. Most companies have gone away from them because they are, even though they are expensive, they're not efficient, and they cause problems for customers down the road. Okay, efficiency and partial shading, like we talked about prior. If one of the panels gets shaded, what happens to the rest of the string? They all start to go down. Okay, so since string inverters require solar panels to be wired in series, if a solar panel's output is affected, the entire series of panels is affected in an equal measure. This can pose a major issue, as some parts of the solar panel series will be shaded while others aren't. It could be something as simple as a bird landing on a panel and sitting down for a few seconds and shading that cell. The entire system is now decreased production because a bird landed on that panel. Part of a cloud is shading half of a panel. Well, the entire series is now affected because of that cloud that shaded the panel. This also goes by the way that we install them. If we didn't take into effect that ventilation pipe or that chimney or the tree, the entire series can now be affected because we didn't take a look at that. More difficult system expansion. This is the problem. This is another problem with it. To get optimal performance from a string inverter, you need to be working with near peak capacity. So which we're talking about, some of them can go up to 155% of its capacity, but we usually install them to that point because it's less expensive for the customer. So if you want to increase the system size of your array at some point down the road, those panels will need to be routed to a separate string inverter, adding an additional complexity, and it adds additional costs. It's got shorter lifespans. So string inverters are warranted between 8 and 12 years, where microinverters have up to a 25-year warranty. System monitoring, panel level insight is not possible. You can't see what each panel is doing on the string inverter system. Since there are no components affixed to the back of the panel to do the job. While aggregated solar production is viewable, so that what that mean by aggregated solar production, the entire thing and what's being converted at the inverter itself, you can't see what's happening at the actual panel. So if there's cracks or defects or debris on the panel, if there's issues with a specific panel, you can't tell what's going on with those. With microinverter systems, microinverters perform the same basic function as a string inverter, which is to convert from direct current to alternating current, except they are installed underneath each panel on your roof. Each of these microinverters are about the same size as your internet router. Some of them are even smaller, and they're about the same size as your phone. They're not very big, and they mount directly to the back of them. The big difference between microinverters and string inverters is the solar panel installation with microinverters will typically have the same number of inverters as the same number of panels. So it's exactly what it sounds like. If you have a 30-panel system, you have 30 systems. They are microinverters. They are mounted at the back of the panel. You have the conversion happening at panel level, and then it transfers it directly down to the actual home itself. Some of the pros of these are new electrical code require rapid shutdown. Microinverters comply with these rapid shutdowns and have the capability embedded in each of the modules themselves. More electricity. The core advantage of using microinverters is that theoretically you can yield more solar electricity. The reason for this is that there are slight differences between the differences in current between the solar panels. So because of that current, because of flow, because of issues, so if a panel gets shaded, the rest of them aren't affected. So you can theoretically produce more power. It's actually, you will produce more power because there is not running a string. They're not running a series, so they aren't affected by what each other panel does. When the solar panels are in a string, the current is reduced that of the least producing panel in the string. Suitability for changing installation conditions. If the solar system is facing multiple angles, so if we have different azimuths, different tilts, all that good stuff, meaning some solar panels are facing south, some are east, some are west, then the microinverters are the way to go. Or if you have shading issues with trees or a large chimney, again, microinverters will be the best. In these situations, the solar panels will be producing different amounts of electricity at different times of the day. The microinverters will ensure you harvest all the energy while standard inverter, you will lose some of its losses in production. The lifespan for is typically about 25 years. It's panel level monitoring. You can see what each panel is doing at all times. And so it's easier to see if there's a problem with the whole system, with the inverter, or if it's just a panel itself. System expansion is easy. You can just add a new panel with a new microinverter on the back of it. The cons are the price. So they're typically $1,000 or more expensive than a string inverter on a standard 5 kilowatt residential solar system. If one of your microinverters were to fail, not only will you be detaching one of the failed to be, hold on, where are we at? If one of the microinverters were to fail, not only would detecting which has been failed to be a challenge, but once you did, servicing and replacing the component will not be easy as popping off the string inverter and putting the new one on the house. Your solar installer would need to gain access to the roof, work with the racking system, unbolt the solar modules, and replace the inverter to reestablish the AC connection. Amount of hardware on the roof, you're putting more weight on the roof. They're not, super heavy, but you're just putting more hardware on the roof. But that could also be a problem, especially if storms, electrical surges, you have more electricity being converted at the roof, which could be considered like a lightning rod type situation. So microinverters have a huge disadvantage there. They're not going to be typically used in the Midwest or in a lot of stormy areas like down in the South, like Mississippi, Alabama, Louisiana, Georgia, Florida, those type of places. You may not want to be using those. Arizona, California, New Mexico, not a bad place to use them. String inverters have an 8 to 12 year lifespan, while microinverters have the 25. You have panel level insight is not passable. Oh, that looks like a repeat. So this is the best of both worlds. This is the power optimizer. This is the type of system that we use as a standard. We use the Solar Edge optimized system. It's a string inverter with optimizers on the back. So microinverters convert DC energy to AC energy right at the panel site. While power optimizers are also located behind the solar panel, they don't convert the electricity on their own. Instead, the optimizers condition the DC energy and send it to a central inverter that finishes the conversion process. The microinverter gives you much more flexibility with your system design. You can build your array in a partially shaded area or split strings across usable space on your roof. Optimizers ensure you get the most production out of every panel in your system. These are usually interchangeable. We have a slide on that. So microinverters and power optimizers are comparable technologies. So comparable that companies describe them as interchangeable. We don't. They are not interchangeable. They are very similar. There's a difference between interchangeable and similar. They're very similar in the way that they work. They're both panel level. They one's conversion, one's conditioning. And then it's still a string inverter, but they are conditioned at the same site. They're conditioned and then transferred at a singular site. But what that means is you can still put them in multiple arrays. You can put them in shaded areas, and it won't affect the rest of the system by what one panel is doing. Both are collectively referred to as module level power electronics, or MLPEs, but are important differences between these setups make them more or less suitable for your installation. Right now, when it comes to SolarEdge, the reason why they're used more often than anything else is because they are more efficient. They are more affordable than microinverters themselves. You don't have to worry about the lightning rods or things like that. You don't have those wiring mishaps that if it's a newer installer or somebody doesn't know what they're doing, you don't have to worry about those type of things because you're not converting at the panel. This is why they're more efficient, and you still have a 99% efficiency rating on the optimizers themselves. With that being said, we ended right at 8 o'clock. It looks like 7:59. So with a minute to spare. So yeah, guys, this is, I know this has been a lot of information. I'm willing to stay back for as long as you guys need me, answer any questions you have. before we hop off, we will be picking this up tonight, tomorrow night. I'm going to, so we don't run across this issue, I am going to do something for you guys and drop tomorrow's training in the Zoom chat so you can copy it. Talk to your manager, ask them to send it to you. If you don't have access to it, we understand. Let's just get it now because we've been having issues with Zoom. I don't know what's going on. Apparently, when we're sending out these invites, they aren't adding to people's calendars. So we're trying to figure that out. Just some tech stuff. That's on Zoom, though. It's not on us. So we'll get that fixed with them tomorrow. But here's tomorrow's Zoom link for finishing up definitions, how solar works, and putting it all together and all that good stuff. So let's go ahead and start your questions. Start asking some questions, guys.
I just don't know how to get this calculator.
No questions? All right. Sharp class. So I have a question for you guys. Are you starting to see as we get further through these definitions, how one definition kind of explained the other one and it started to make more sense from something that we were talking about earlier?
Yeah, for sure.
Okay. So this is why I tell you guys, like, it's don't feel overwhelmed. Like as we go through this, it's like, okay, cool. Tilt does affect this. Azimuth affects this. We have to do this in order to get this. They will come in. You will make mistakes. You will forget some stuff. That's not a big deal. It is always better just to go for broke and tell your customer, I don't remember this. Let me call my boss. I will find out for you. I don't know. Let me find out for you. Get on the phone with your manager. We will get you that information. You will never be alone. We will always have somebody here to answer a question for you. We will always have somebody here to help you through that process. We don't expect you to know all this stuff overnight. The certification test that we take on Saturday morning is a very generic one. It's a multiple choice, right? So if we have something about azimuth, we're going to be asking you azimuth based off of, like, hey, what compared to a compass, right? So what is 180 degrees? Well, that's south. Okay, great. What's 45 degrees? Well, that's northeast. What's 0 degrees or 360? That's north, right? Those are the type of things I want you guys to get. The very in-depth stuff you guys will develop more over time as you're doing it. But as long as you understand the basics, you're already being trained about 99% more today than most people have gotten from a solar company in their entire careers. Most people aren't trained this stuff. We find that as a problem. This is why we teach you. Are you going to end up using all of it every single time? No. Are there going to be cases when you need to know it? Yes. But the important part is because you know this stuff, you can better explain it to your customers, get better consultations, and be a consultant and not just be a salesperson trying to throw a dollar amount at them hoping that it sticks.
Yep.
Okay.
I didn't think that there was so much intricate things that you have to know. Like, we think about like selling solar. It's like, oh, you just slap some panels on the house.
Yeah.
I guess you don't really take in, you know what I mean, until you're actually here. That's crazy.
Yeah.
So, yeah, I like it, man. I like the good stuff.
It's gonna help you guys when you're talking to your customers, because one of the biggest things that you hear when you're setting appointments, can you just give me like an average? Like, what's the average? Well, I know what the average that we sell in the state is, but it has nothing to do with you, right? So what do we say? Actually, there is no specific average because there's no two homes that are alike. Because even if there's the same design, are there the same people inside the house? Do they have the same habits? Do they have the same toys? Do they have the same games? Do they, this person's a gamer. They have a huge gaming rig. This person has an electric car. This person has a pool and a hot tub. This person heats their pool and hot tub. This person has 2 hot tubs. This person has jets in their bathroom. This person, right? This person has a bidet, right? Is that what it's called? That shoots the water on the toilet, right? Right. All
Looks
these
like Bellagio.
that are inside the houses, we don't know. We have no idea until we get a copy of that bill.
Yeah.
Right? Can you give me an average? Yeah, perfect. Go give me a copy of the electric bill and I'll go ahead and get you that average. That's literally what you say. It's like, well, the average in Arizona is about this. What if you tell them the average in Arizona is 8 kilowatts, but they spend, they actually need a 12 kilowatt system.
Yeah.
Right. That could have a big impact on you and the trust and credibility that they have with you. I've been in a couple of proposals training a couple of these managers recently where, you know, they have a certain, and these are new builds. So we do projections. We are the new construction specialists for a reason. We project within 99%. Like we know based off of, we go off of everything. What type of electronics do you have inside the house? What type of washer and dryer do you have? How old is it? What type of fridge are you using? How often do you open it? How many people are inside the house so we can determine the body heat factor? What do you like your thermostat at? What type of thermostat do you have? You know, what do you plan on doing with the house? So we just moved in. Fantastic. Great. So do you have usage yet? No. Okay, great. Yes, I do. I have 3 months. Fantastic. And we're going to build that out. We're going to project to the day, the very next year, what they need as far as kilowatt hours. We're right 99% of the time, right? There's that 1% where we're a little bit off, but as soon as we start getting those electric bills in, because we have 2 months before they get installed, that gives time to get 2 bills and we can see those habits and okay, we do need to make some adjustments. Here you go. And the customers are happy. I have one customer literally based off of her needs. She only needs an 8 kilowatt system. She's only going to be in the house for 3 years. She's given the system to her son and given the house to her son. And it's going to go from 4 people to 1 person. And he's still going to have a pool. He's still going to have the hot tub, and she's doing this really wonderful thing for him. And that's awesome. But is he going to need a 14 kilowatt system like was being projected to her? No. There's only going to be 4 people in the house for 3 years. So does she care about what she needs now? She's like, I want to save a little bit of money now, but I don't want to oversize the system. Because when she said, based off of this, it looks like it's not a good investment. So I had to start asking some questions. And I asked the questions, I found out, and yeah, you're absolutely right. It's not a good investment. And it's because you're calculating it correctly and nobody else was. She had 4 different quotes. Every single company gave her a different quote, all between 13 to 14 kilowatts because they're trying to save their own butt, which is completely fine. We do it different here. We're going to ask the questions. We're going to get down to the nitty gritty, find out what they need, how they need it, and we're going to get it done right. And we're going to consult them on why that is. And instead of saying, okay, cool, let me look over these, guess what she said? Great. This is what I thought I would need. This is my projections. Ends up being that she's an engineer. She's super smart. She's already gone through this. She did the same type of thing I did. We were right on the money. Okay. I did it for her neighbor 2 years prior. He hasn't seen a bill since. This is what we do. Right. Yeah. Any other questions? Cool. I like you guys. Get out further tonight. All right, I'm gonna work on this website. Don't worry about getting onto the website and getting your stuff up tonight. I don't know what the issue is. Tech keeps getting it up and down. It looks like it's a problem with the server itself, and it has nothing to do with what any of us are doing, which is kind of a good thing. It means that we can just call our server provider and have them fix it. So they need my passcodes and stuff, so I got to hop on the phone. So I'm going to do that. I will be available by text if anybody needs to text me. Do you guys have my phone number? Most of you don't, actually. Let me put it up here for you. Yeah, tomorrow we're going over system size, and that's a fun one. I'm going to drop in the chat 520-975-9575. That is my cell phone number. Feel free to text me and I will respond by text. My cutoff is 10:30. So don't text me after 10:30. Anytime before that, I will respond to you. Yeah, other than that, it's been great, guys. I really enjoyed this training. I really enjoyed going through the stuff with you. And I look forward to tomorrow's. Tomorrow's, we're actually going to start having some more fun with it. We're going through the nitty gritty. We're actually going to be sizing systems, how that works. You're going to see how that works. And then right after that, we're going into what solar batteries are. I believe Brian's going to be presenting that stuff to you guys. And then we're going to start going over how to set an appointment so that you guys can start setting some appointments. And we should end right at 8 o'clock again. And that way you guys can start capitalizing on the rest of your week on Thursday morning so that you guys get appointments set for Saturday so you guys can make some money for next Friday's paycheck. Other than that, let's do this, guys. Shoot me your questions, texts, concerns, grunts, gripes, moans. I'm here for you. Have a great night.
Right on. Thanks, Chris.
Good night. It's a
You.